The Genie logic relay has 16 timers. We can select these timers by selecting on the timer button on the toolbar. If we wish to add a timer to the logic, we can click on which one we want, T1 to T16. In this case we will choose T1, and we'll click on a coil column, and we have added timer T1 to the end of that rung. Now it is showing there as being T1. That means T1 trigger. We can change the coil from being a trigger to a reset by right clicking and coming down here. We have a choice of trigger input or reset input. If we select reset input, we get RT1, which is the reset for T1. Let's put it back to trigger input. Now to operate our timer, we need to have something to trigger it, so we will use an input, and I'll add I1. I1 being the external input, so we have a circuit connected to I1, it will trigger the timer. To set the timer up, we need to adjust its properties. Right click, come down to properties. This brings up a dialog box. The first point in the dialog box is locked, yes or no. If the timer is locked, so we click on the yes, then no parameters within the timer can be changed while the program is running. So we cannot change it from the front panel of the logic relay. If it is no, it's not locked, then we can change it from the front panel of the logic relay. Here we have T1. We are working with timer T1, but we could be working with any of the other timers. In this case, T1 is the one we want. There are 4 modes of operation for the timer. We have mode A, which is on delay, B off delay, mode C is single pulse, and mode D is asymmetric. With the on delay timer, when we operate the trigger, there is a time delay T until the output of the time relay operates. This time T we can control by using the set point, and it can be adjusted in seconds, minutes and seconds, or hours and minutes. So we could set that to say 10 seconds. If the duration of the trigger pulse is less than the operating time of the timer, then we will get no output as shown on this timing diagram. If we want to shorten the length of the timer output, we can apply a reset to chop it off. Otherwise it will stay high until the trigger input goes low. The second option is the off delay. With the off delay, when we operate the trigger, the relay output goes high at the same time as the trigger goes high. And then when the trigger goes low, there is a period of time where the output of the timer relay stays high. So it stretches the pulse out by the time programmed in this area here. Once again, exactly the same, seconds, minutes and seconds, or hours and minutes. So we can shorten the time by using a reset pulse. So if we have our off delay set for 10 seconds and we apply a reset pulse after 5 seconds, then the output pulse will be 5 seconds after the trigger pulse goes down. The third option is single pulse. With single pulse, we can set the length of the pulse with our set point down here again. The relay is triggered on the rising edge of a trigger, and the relay output will stay high for the length of the set point. So if the trigger is a very long pulse, we will end up with a much shorter relay output. If the trigger duration is shorter than our set point, we still end up with the same amount of time. The only way to reduce the time on that output is by once again applying a reset pulse. The fourth option is the asymmetric pulse. The asymmetric timer has got an on time and an off time. When we set the trigger input, the relay output immediately goes high. It stays high for the period nominated as T on, and then it goes low and stays low for the period nominated as T off. Then goes high again for T on, off for T off. Effectively we have an oscillator, and this oscillator will stop when we apply a reset to it. So once it is triggered and running, it continues running until we apply a reset. We can program the set point on or T on, and we can program the set point off or T off. So for our first example, we're going to use an on delay timer, and we're going to set that for 10 seconds. So on this configuration here, if I close onto I1, I trigger the timer and the timer will operate 10 seconds later. But on this current diagram, nothing is going to happen. We actually need an output for something to happen, so let's put an output on there. Q1 and a Q1 here. This is a relay output. That relay output is not going to do anything though unless we tell it what to do. So we'll tell it to operate when the timer operates. T1 on here. And now, if we put a trigger into I1, we pulse into I1, and we hold that pulse there, then after 10 seconds, output Q1 will turn on. We can see that in the simulation. We go up to the menu bar at simulation, go with PC because we don't have a device connected. No outputs on, no inputs on. I now turn on input 1. Input 1 is now turned on. And 10 seconds later, output 1 turns on. If I now turn input 1 off, then output 1 turns off with it. Okay, stop the simulation. Now if I wanted to make an output that pulsed a flashing light, and I wanted that flashing light to flash for 10 seconds, then I would add a timer, we'll call that T2, and that timer would be an asymmetric timer. Set out properties, asymmetric, and we're going to have 1 second on and 1 second off. Now we're going to trigger that off I1. So let's go back up to our inputs here. I1, I1. It's triggered off I1. But we're going to reset it when T1 operates. So we'll put another timer back in here again. T2 again, and we're going to change that to a reset input, and we're going to put our T1 here. Now we want that to operate a lamp on the output, so put T2 up here again, and we're going to put an output Q2. So what this will do is when we close I1, then T1 will stay low for 10 seconds and then it will go high. As well as that, when we close I1, T2 will start oscillating, 1 second on, 1 second off. When T1 goes high, it will then reset the timer and that oscillation will stop. When T2 is oscillating or pulsing, we'll get a pulsing on relay 2. So let's apply a simulation to that. PC. Put this down where we can see it out of the way. Okay, so nothing's happening at all at the moment. Now we close I1 and output 2 is oscillating. Output 1 is now operated and output 2 has stopped. Okay, so that's how you can use the timer for doing things.